This one here is a tricky one. Here I've got, plot these on a graph. So they do form a linear relationship because I've got a straight line. Then it's looking for the formula connecting them. Now, basically what you're looking for is the equation of a line. That's what they're asking you for. Y minus y1 equals mx minus x1. Only you don't have y's and x's. You've got T for temperature and L for length. So instead of having y's now, I'm going to call it length. Length minus a length point equals m, a temperature minus a temperature point. M's just ordinary, difference in y's over difference in x's. I'll just take it from my table here, take any two values. I'll just go for those two values. So the m is difference in y's, but your y's is l's. So difference in l's over difference in x's. Your x's are t's. So pick any 2 points from your table. The difference in the l's is 25 minus 21. The difference in the t's is 50 minus 10. So the gradient there is 4 over 40, which is a tenth. Sorry. So it's difference in L's over difference in T's. So instead of X's, instead of Y's, you've got L's. Instead of X's, you've got T's. So the difference in the L's, I just picked these 2 points, 25 minus 21, over the difference in the X's, 50 minus 10, giving you a gradient of a tenth. So plugging that in, so L minus L1 equals a tenth T minus T1. Now T1 and L1 is just like your X1, Y1 from your equation. It's just any points. I'll go for the first one. So the L is 21. So L minus 21 equals a tenth T minus that T temperature. You can multiply that out if you want to tidy up a little bit. And then I'll just finish off bringing that 21 over to our side. It becomes adding. So you have a tenth T, add 20. So basically that's a fancy way of asking you to find the equation of a line. Now that is quite complicated, but if you think of it in terms of x's and y's and change them to t's and l's, it makes life a lot easier. Now, question 2. Plot these on a graph. I don't have the axis drawn out here, so we'll do that now. Distance will go along the bottom and have to go up to 15, so we'll mark that off as accurately as I can. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's distance. Make sure you label your axes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And up the side is the fair. It has to go up to 25. So 5, 10, 15, 20, 25. And that's the fair. So 2 goes up to 550. 5 pounds or 5 miles up to 10. 8 up to 1450. 10 up to 1750. And 15 up to 25. And again, you can see it's a linear relationship. It's a nice straight line. Determine the length of the journey for which the fare is 1150. Let's go across 1150, go up and read across. So for part B, 1150 is about here and across 20 miles. And for part C, determine the call-out charge. That means before you go any miles. So the call-out charge looks about £2 before you do any driving. The next one I want to look at is on page 274 of the textbook. So 274 and question 3. It's a distance time graph. So understand it first of all, time along the bottom, work out what each wee square is worth. 3 wee squares is for 30 minutes, so 1 wee square will be 10 minutes. And up the side, each wee square is 2.5. Who travels further? Well, Claire goes 30 miles and Dermot only goes 20. So Claire. Work out the average speed which each of them is travelling. Now, average speed. When I talk about the average speed, it's a speed for the whole journey. So for Claire, remember the speed is distance over time. The distance is 30 and it takes her 1 hour, 30, 40, 50 minutes. So we'll do Claire first. So Claire, her speed is distance over time. Her total time was 30 miles. Sorry, her total distance was 30 miles. Her total time was 1 hour and 50 minutes. Now you must change that into hours. So it's 30 miles and 1, to change minutes into hours, it's 50 over 60 of an hour. So to do that in your calculator, it's 30 divided by 1 and 5/6. Now you can just use your refraction button there. I think we should, or you could do it out the long way, which I'll show you. 1 times 6 is 6, add 5 is 11. To divide by fractions, you turn them upside down and multiply. So that's 150 over 11. So 150 divided by 11 gives you a speed of 13 miles per hour. 13.6 miles per hour.